Hello, and today we'll be doing experiment PE2, which is 6-pulse fully controlled 3-phase bridge rectifier. So here we have the circuit. Built in the program PSIM. So in experiment 1, we shall be observing the different waveforms of different firing angles of the circuit. So first we have this at zero amplitude, and then we simulate, and here we look at waveforms VR, V alpha, VDC, and IDC IR. Next we look at the firing angle of 30, and we simulate this. Here is the waveforms for firing angle 30. Now you go for firing angle 60, and then firing angle 90, firing angle 120, and lastly firing angle 180.
Next is experiment 2. We have to observe the VDC value for the different firing angle. Here we start at 0 firing angle. Here the value of the VDC average is 105.059. Next, firing angle equal to 10. The value of VDC average is 103.346. Next, firing angle equal to 30. The value of VDC average is 91.0288. Next, firing angle 60. The value of VDC average is 52.0698. Next, firing angle 90. The value of VDC average is 13.5450. And lastly, firing angle equal to 120. The value of VDC average is 0.003646.
Okay, for experiment 3, we can find the waveform for IR, IY, and IB. Okay, firstly, we have to change the angle first. We change the angle to 0. Then we run the simulation. After that, after we run the simulation, we can find the waveform for VR. This waveform for VR. The waveform for IR. Okay, this is for waveform for IR, and next is waveform for IY. Okay, this is waveform for IY, and then lastly, waveform for IB. Okay, this is for waveform IB. So this is all the waveform. After that, after we run the waveform we find the waveform for this for waveform. Okay, we can create FFT to find the waveform for FFT. After we run the FFT simulation, and then we can find the value of total harmonization for the 50 frequency. All right. Okay, we can see the IR THD is the value is 3.08072. Okay, that's all for our experience. Thank you.